Okay, we are very quickly going to go through a algebra radical review. We are going to be doing simplifying, multiplying, adding, subtracting, and dividing. Problem number 1. We are going to reduce the square root of 20. Now, if you remember from algebra, there's a couple different ways you can do this, but you are looking for the perfect squares that are in that number. So what I teach my students in algebra is to do the prime factorization tree. You end up with 2 times 2 times 5. You circle your pairs. Take one number from each pair. This goes on the outside. Whatever is left gets multiplied and put back under. The way to check what you have done is to go backwards. If I need to put the 2 back under the radical, I would have to square it. So 2 squared is 4. 4 times 5 is 20. That's what I started off with, so that does check. Problem number 2. Square root of 72. I'm going to do the same thing. Now eventually you're not going to have to use the prime factorization tree. Some of you may have been taught by putting this into perfect squares. There's a bunch of different ways of doing it. 72, I know, is 8 times 9. 8 breaks down to 2 times 2 times 2. 9 breaks down to 3 times 3. So same thing with this one. Circle your pairs. Take one number from each pair, so taking a 2 and a 3 and getting 6. The garbage left that's not circled gets put back underneath the radical. And again, to check it, if I need to put it back under the radical, I'm going to square it. So 6 squared is 36 times 2 gives me 72, and that's what I started off with, square root of 72. Number 3, if we have 2 times the square root of 32. So now this is the first time we've had a number outside the radical. So what we are going to do is we are going to prime factor just the square root of 32. 32 breaks down to 8 times 4. 8 is 2 times 2 times 2. 4 is 2 times 2. So if I circle my pairs, 2 times 2 is 4. The garbage left over is radical 2. But you have to keep in mind that this is just the square root of 32. So this is the 4 square root of 32. It's understood that there's a multiplication going on here. So 2 times the 4 that is now out gives me an 8. And I still have the radical 2. So that would be my answer. Continuing on to the next page. Square root of 6 times the square root of 8. You have a couple different options. You can simplify each radical, which a lot of times that does help, or you can just multiply them together and then simplify that one. So I would get the square root of 48. So if I break down 48, that gives me 8 times 6, 2 times 2 times 2, times 2 times 3, and circle my pairs. So this gives me 4 radical 3, and that is my final answer. If I have 2 radical 5 times 3 radical 2, when you are multiplying, the numbers outside get multiplied and create a new number outside. The numbers under get multiplied and it creates another new number under. Square root of 5 cannot be simplified. Square root of 2 couldn't be simplified. Just because these two can't be simplified does not mean that it's not going to create something that needs to be simplified here. So I do always need to check. Square root of 10 breaks down to 2 times 5. No pairs to take out, so square root of 10 is simplified. So 6 radical 10 is my final answer. Number 6, getting some bigger numbers. 5 radical 48 times 3 radical 12. Now if I multiply 48 and 12, that's going to get a really big number. So I'm going to choose to simplify each radical individually. Square root of 48 we did up here, so I'm not going to do it again. Square root of 48 is 4 radical 3. Don't forget about your 5 that you have, so that is 20 radical 3 times 12 I know is 2 times 2 times 3, so I have 2 radical 3, but again don't forget about your, that is 2 radical 3. Don't forget about your 3 that you already have, which gives me 6 radical 3. Simplify, outside gives me a new number outside. 3, square root of 3 times the square root of 3 gives me the square root of 9. But what is the square root of 9? It is 3. So I have 120 times the 3 gives me 360. Number 7, 2 radical 3 plus 5 radical 2. 2 radical 3 plus 5 radical 2, we are adding, so it does not have the same rules as multiplication. The rule with adding is that just like adding fractions, you have to have the same denominator. You have to have the same number under the radical. You do always have to check and make sure that it is simplified first. So 2 radical 3 plus 5 radical 2 cannot be simplified. They are not the same number under the radical. So that is your answer. Problem number 8. 5 radical 3 plus 6 radical 3. Now I have the same number under the radical, so I add the outside, so I have 11 radical 3. Another way of thinking about this, going back to algebra, is that if this were 5x plus 6x, that would be 11x. You keep what is the same. We're doing the exact same thing here. Number 9, going into fractions. There's a rule that you cannot leave a radical in denominator of a fraction, so we have to do what is called rationalizing. Whatever radical is in the denominator, you use that to form what we call a well-chosen one. So I can multiply this by the square root of 3 over the square root of 3. Doesn't the square root of 3 divided by the square root of 3 give you 1? So again, I'm not changing the value of this, I'm just changing the way that it looks. Just like multiplying fractions, you multiply straight across. 2 times radical 3 is 2 radical 3. Radical 3 times radical 3 is square root of 9, which gives you 2 radical 3 over 3. You cannot simplify these 3's because one is under the radical, one is not. If 2 and 3 had something in common, then yes, they are both outside the radical, so we could simplify that. Number 10, 4 radical 5 over 2 radical 10. Okay, this one's a little bit different. We have numbers outside that have something in common. We have numbers under that have something in common. Okay, so because we have a 4 and a 2 that have something in common, and a 5 and a 10, I can simplify. 2 goes into a 4 twice, 2 goes in here once. 5 and 10, 5 goes in here once, 5 goes in here twice. That 2 is still underneath the radical, so if I clean this up, remind you that the 1's don't mean anything. Now I'm back to rationalizing, which is what I did up in number 9. Figure out what the radical is down here. So I'm going to use that radical and form it into a 1. Radical 2 divided by radical 2 is 1. Multiply straight across. 2 radical 2 equals the square root of 4, which is 2. What But I have to look again. 2's can cancel or divide out. Everyone look at it. And your answer is the square root of 2. That concludes your radical review.